At the third section, so we've completed the script till checkpoint B, and this is what our script looks like. We started with the pentad collection. We created a start date, which is the 2019 1st January, advanced it by 1 year, filtered it for all the images in 1 year. We have 72 images now, and then we have the start and end dates. Now, this is the core part of the chapter where we need to take the 72 images and convert them into 12 monthly images. So let's see how to do this. The technique for doing this consists of three parts. First, you create a list of numbers which represents the unit that you're trying to aggregate to. So here we are trying to aggregate to 1 image a month. So we need to create a list of months which we can use as input. So we have 12 months in a year. So we'll create a list of numbers from 1 to 12. That'll be the input for our function where we'll say, I want to now create images for month 1, month 2, and so on. If you wanted to create yearly images for 20 years, you create a list of those 20 years. So whatever unit that you want to aggregate it to, you first create the list representing that unit. So here we'll create a list of months. So I want to create a list of numbers from 1 to 12. And to create this, we have a function called eelist.sequence. This is a great function that allows you to create arbitrary long sequences. So we'll just use this function, ee.list.sequence. And we can give a start number and an end number. There's a third optional parameter. Or if you want to skip one number, if you want to generate every alternate number, or if you want to generate, create 5 yearly time series. So you say 1, 10, and then skip 5. So you'll get 1, 5, and 10. Let's print this. And you'll see that now we have a list of numbers from 1 to 12. So this is the first step. If you are working on, say, I have 40 years of precipitation data, I want to create yearly precipitation. How do we do that? Well, first create a list of numbers from 1980 to 2022. You have your list of years, and then you do the next step. The next step is write a function that takes the unit as input. So in our case, a month as input and generates an image for that unit. Returns the image for that unit. Okay. So we'll write that function that just takes one input and returns the image for that unit. In this case, we want to create monthly images. So I'm going to name my function as create monthly image. This is a function that takes only one input. We're going to just name it as beginning month. So given a beginning month, we want to create the image for that month. Okay. So we want to now create, take this month number and then create images for that month. We have the month number, we have the year saved in this variable. So how do we get all images for that month? Well, we create a start and end date. So we'll create a start date first. So we'll just say start date is EE date from YMD. We say year is the year variable, month is the beginning month. And then the date is 1. Right? So this create the start date at the beginning of every month. And now we can see why using this function is important, because now you can create this programmatically. If this function is called with number 2, the start date will be the 1st of February. If this function is called with number 3, it'll be the 1st of March, and so on. The end date will be start date dot advance 1 month. Since we want monthly images, we have the start of the month. We just advance it by 1 month. We have the end date. We have the start and end date. How do we get all the pentad images for that month? We'll just filter them. So we'll take the year filtered data. So This is the year filtered. This is all images for the year. We'll apply one more filter. And we'll say EE filter date, start date, and end date. Okay, so we have all images for that month in this variable month filter collection. Now we want to just compute what was the total rainfall for that month. We can use the reducer. We'll just say total is month filter dot reduce EE reducer sum. So my total image will be the total monthly rainfall for that month. And once we computed it, we just return that. So now, given a month number, you'll get the total rainfall for that month. And this is the same concept if you're doing yearly compositing, if you want to do yearly composite from Sentinel-2 images. The same concept. You write a function that takes year as the input, create a date beginning of the year, advance it by 1 year, filter your collection for that year, do a median composite, and return that. Right? In case of precipitation, we need to sum it because the rainfall is summed over the period. So here we apply the sum reducer. The third step, I'm going to finish this function. This function is still not complete, but I want to just show you what is missing here. So first step, create a list of all the units. Second, write a function that takes that unit as input, returns the image for that unit. And then third step, map the function over the list of units. So now we'll just say, I want monthly images. So I'll take the list of months and map that function, whatever function we wrote, onto that. This line of code will run this function for every item in this list in parallel. The map is important because this is not going to run one after the other. It's going to run it in parallel. And that means it can leverage the full computational resources that Earth Engine provides. So this will run this function on each item from this list, and you'll get this 12 images. Let's see if everything worked. Okay, so we have the 12 images, and we had 12 list of 12 numbers. We mapped a function on those. Each function returned an image. So now we have a list of 12 images. And you can see each image has the band called precipitation sum, which is the sum of precipitation for that month. You'll notice that these images do not have any properties. And that means in Earth Engine, all the images in an image collection are required to have at least one property called system:timestart, which indicates the timestamp of the image. Without that, a lot of functions won't work, filters won't work, charting functions won't work, etc. Also, if you want to identify that which month does this image belong to, there's no easy way for us to identify that. So let's fix that. We can, before returning this image, we can use the set function and set some properties. So the set function can take a dictionary. We can give a dictionary of all the different properties that we want to set. So let's set some properties. I want to set first a system:timestart property. This is a mandatory property that is required for Earth Engine images. We have the start date. The system:timestart has to be a timestamp as integer. We already know how to take a date object and convert it to the timestamp using the millis function. So we'll do this. So this will convert that start date into number of milliseconds since 1970, 1st Jan, and store that as an integer. Similarly, we can store system:time end. This property is not required, but useful to have around. So we'll just say end date.millis. We'll also add some other properties to help us filter or identify each image easily. We'll just say year of this image is this year, and then month of this is the month variable. And now when I run this, you'll see we have the same 12 images, but now each image has 4 properties: the month that the image belongs to, the year, and then the system:time start and time end. Okay, and you have this for every image. So we have now aggregated this pentard collection into a monthly collection. But we are not done yet, because what we get out of this is a list of images. A list of images is okay, but for Earth Engine to work with images, you need to have an image collection. If you have an image collection, you can do filters and apply all sort of functions. A lot of the charting functions will require an image collection, so on. So we need to take this list of images and create a collection. So let's create a collection. We'll create a monthly collection. And to create a monthly collection, we have to a collection from a list of images, we have this helper function, e.imageCollection.fromImages. And we give it a list of images, which will turn that into a collection. And now I want to print this monthly collection. And you see, we have a list of images here. And now this one is a collection from those 12 images. Okay. And this is our checkpoint C. We have completed this. This is the core part of aggregation of time series. Again, to recap, if you want to take your original collection and aggregate it to another unit, first create a list of those units, list of months, list of years, create a function that takes one of those units as input and returns the image for that unit. And then take your list of units and map that function over it, and you'll get a list of images for each unit in your list, and then turn it into a collection, and you are ready to